Now let's look at lesson 3.7, equations of lines in the coordinate plane. We can graph a line and write its equation when we know certain facts about the line, such as its slope and a point on the line. So in all of these problems we're looking at today, there's one main common characteristic, and that's going to be that they all have a slope of some sort. So it's important to always know that we can find the slope, and sometimes we're going to need one other point, because 2 points you can make a line, and if you know the slope, you can find that second point. At the slope. Now, by definition, the slope, which we use the letter M of a line, is the ratio of vertical change, the rise, to the horizontal change run. And one way you're going to see me denote it is you're going to see me write delta y over delta x, which stands for the change in y over the change in x, which is our rise. The change in y is our rise, and the change in x is our run. So with that, you're given 2 points in a coordinate system. You're going to have y2 minus y1 and x2 minus x1. Remember that these are just ways that we can name one point to the other, point 1 and point 2. Doesn't matter which point you choose first, but if you choose the second point first, you need to choose for x and y, both of these should start with the second point. So when we find the change in something, we're finding the distance between it, which is the difference, and we're going to subtract. So let's take a look at an example of finding a couple different equations. Find the slope of the lines. So we're going to look at the slope of all different lines. We're going to take a look at line B, line D, line A, and then line C. Now, before we start, it's always important to identify the line and find any points that they give us. Now, if they give you the graph, you can actually count to find your slope. You would count your rise over your run. But it doesn't always give you the graph of the line. Sometimes it just gives you the points. So let's take a look. If I was going to graph for line B, I have a point here and I have a point here. I could see, how do I get from this point to this point? Well, we always do our rise and our rise first, then we do our run. So we're going to rise 1, 2, 3, 4. Since we went down, we say that's a -4, and we go 1, 2, 3, 4, 5 to the right, so that'd be a -4/5. So when we go down, we say it's negative. When we go to the right, we say it's positive. So we'd say we have a -4/5 slope. But another way to look at that is by taking the points. So if I just start with the point, the first one I see is -1, 2. Write those points down. And now what we're going to do is what we call stack and subtract. Stack them up and subtract them. We know our x comes first, then our y. Okay, so we're going to find the slope. So m is equal to the change in y over change in x. So we're going to take 2 minus a -2, and we're going to divide it by, since we started with the top one here, we're going to start the top one here, -1 minus 4. Now once again, we have to go back and change our sign, so we're going to change this to positive here, and this gives us a 2 plus 2 is a 4, -1 and a -4, it gives us a -5, so we get a -4/5. Now we don't typically write the negative in the denominator, so what we'll do is we'll rewrite this as either putting it in front, -4/5, or we'll attach it to the numerator. But when you're graphing this, when you're plotting you're applying your slope, you're either going to put the negative to either the 4 or the 5. But you cannot do both. So it's going to be, the negative only goes with 1. So now using this, I want you to find the slopes of line D, A, and C. So pause your video and come back and check your answers when you're done. All right, So as you look through here, we take, for line D, we have points 4, 0, and 4, negative 2. So we do 0 minus negative 2 and get positive 2. 4 minus 4 is 0. So when you get a 0 in the denominator, the slope is considered to be undefined. If you plugged 2 divided by 0 in your calculator, you get a math error, or you get an error. That's because we cannot divide by 0 in math. Now, if you go over to the next one, for line A, we take 5, 7, and 2, 3. 7 minus 3 is 4, 5 minus 2 is 3, so we get 4/3. So the slope of this one is 4/3. This is line A. That means for any point, we're going to go up 4, and we're going to run 3. And the last one for C, we're using the points 1, 7, and 5, 7. This is a horizontal line. We have 7 minus 7 is 0, and 1 minus 5 is negative 4. Now this one's not undefined. Anytime you have 0 in the numerator, your answer is going to be 0. So if you have a horizontal line, you have a slope of 0. It's not rising or falling at all. If you have a slope that is undefined, it's going to be a vertical line. If your line falls down here, if this line starts to fall, it's going to say we have a negative slope. If it rises, we say it has a positive slope. So let's look at that and see how we can remember. If we look at the sign of the slope, which helps determine whether it's going to fall or rise to the right. So just like you read a book from left to right, you read a graph from left to right. This is true whether it's a quadratic equation or a cubic equation or just a line. You read it from left to right. A slope of 0 tells you that the line is horizontal, and an undefined slope tells us that the line is vertical. So here we have a chart to kind of help us remember. Positive slope is up to the right. Negative slope is down to the right. We have a 0 slope, horizontal, and an undefined slope. All right. So now let's look at the forms of linear equations. The 3 forms we're going to look at. The first one is slope-intercept form. Y equals mx plus b. We're going to use this form when we know the slope and we're given the y-intercept, which is the b. This is probably the one you're most used to. In point-slope form, it is when you're given a point and a slope. So if you know the slope and a point, you're going to use point-slope form. Or if you're given 2 points, you'll have to use point-slope form as well. So this is where we take y minus the y-coordinate equals m times x minus the x-coordinate. This is where x1 and y1 is your point that you know. M is your slope. And the last form is standard form. Standard form is ax plus by is equal to c. This is the standard form of a linear equation. A and b and c are real numbers, and a and b cannot both be 0. One can be 0, but not the other. So, a lot of different people have different opinions on this. It's whether your a value here, the number in front of the x, has to be always positive or can be negative. Most of the time you're going to see it as they are positive x values, but it all depends on typically the textbook you're looking at, because some textbooks don't care. All right, so let's take a look at graphing the line. What is the graph of y equals 2/3 x plus 1? Well, the first thing we want to do is we want to identify the two main parts. Our slope, which in this case is going to be 2/3, whatever is multiplied by x, and then the b, which is the y-intercept, and that's going to be 1. So another way to write that is y-intercept, where it crosses the y-axis. So the first thing, this is our starting point. We're going to go to that point. Now it's going to be on the y-axis, y-intercept, so we're going to go to 1. Now we're going to take our slope and apply our slope. So we go to that starting point and we're going to go up 2 and we're going to run 3. So rise 2 and we're going to run 3. To kind of show you it again, if we go up 1, 2, 1, 2, 3. And now if we were going to go down this way, we would go, instead of rising 2, we're going to go down 2. So down to 2, and then we're going to go left 3. The reason we're going left is because this is a positive value, positive slope, which means that another way to, if I go down and left, that's another way of saying negative 2/3 is the same thing as a positive. Negative 2 over negative 3 is the same thing as a positive 2 over positive 3. Now, as we graph our line here, we will see our line lines up and it goes through all our points. Now remember, you only need 2 points to graph a line, but the more points we get, the better picture we see of what our line looks like. All right, so this is a graph in slope-intercept form. Now let's look at the graph that is in point-slope form. All right, so the equation is y minus 5 equals 2 parentheses x plus 3. This is the equation y minus y1 equals mx minus x1. Notice in our equation here, it is always subtracting your x and y value. So the first thing we're going to do is we're going to identify our slope. Slope in this case is going to be whatever the m is. M is up here, which is going to be 2. Now we need to find our point. Well, the way we identify our point is we take the opposite of what it is in our equation. So if it's by the x value, then this is our x coordinate. So this is 3 is by the x. It's a positive 3, so opposite that would be a negative 3. So this is a negative 3. And since this is a negative 5 by our y value, we're going to say that our y value is a positive 5. So you take the opposite. Now this becomes our starting point. So we'll come in here and we will graph our first point at negative 3 and positive 5. So now we're going to go a couple places up and a couple places down. So if our slope is 2, this is the same thing as saying it is 2 over 1. We need to rise in our run. We're going to rise 2 while we run 1. So from here I'm going to go up 2 and over 1. Up 2 over 1. From here I'm going to go down 2, left 1. Down 2, left 1. And then we have a pretty good idea of what our graph looks like. So then you just take your straight edge and you graph it and you can see what the graph should look like. So this is it's got a positive slope, so once again notice it's going from left to right, it's going up to the right. All right, so now let's take a look at one in standard form. Standard form is the 3x plus 4y equals 12. This is ax plus by equals c. Now in order to get this into graph it, we're going to, you can do two things. You can either use your x and y intercepts, or you can take this into slope-intercept form. And I want you to take it into slope-intercept form for this lesson. So we're going to take our equation 3x plus 4y equals 12, and we're going to solve for y. We want to get this into y equals mx plus b. So we want to get y by itself, so that means I got to get rid of the x. So I'm going to move 3x over here. Now I can't combine the 12 and the negative 3x because this doesn't have an x. So I'm going to put it in the order we have, negative 3x plus 12. And now I want to get rid of the 4, so the y is by itself, so I divide by 4. Now I'm going to divide each part by 4. I know I drew the whole line there. We're going to divide each part by 4. So y is equal to a negative 3/4. If it can reduce or simplify, you would always reduce it. This right here, 12 divided by 4 is 3, so our equation is going to be y equals negative 3/4 x plus 3. Now we should notice the negative sign here. This means that our graph has a negative slope. So now I'm going to look to see what I've got. I've got the slope and I've got the y-intercept. Y-intercept is the 3, so I mark the 3 here. Now I'm going to apply the slope of down 3, and run 4. Down 3, 1, 2, 3, and run 1, 2, 3, and 4. If we go any more this way, it'll be off the page. So this over here, let's go up a couple. So we're going to go rise 3 this time, and we're going to run negative 4. So 1, 2, 3, 4. Once again, rise 1, 2, 3, 1, 2, 3, and 4. And this is, as you can see, is a negative slope because it falls to the right. All right, so far we've looked at it, graphing a line in slope-intercept form, point-slope form, and standard form. I want you to pause the video, and I want you to graph the equation y minus 2 equals negative 1/3 x minus 4. So pause the video now, come back and check your work when you're done. All right, so as we look at our equation, we're going to be using the point-slope form, y minus y1 equals m x minus x1. So the point we're using is going to be at 4 for the x and 2 for the y. Our slope for this equation is the negative 1/3. So we're going to plot our point, and our first point here is at 4 on the x, 2 on the y. This is our first point. So now we're going to apply the slope to this point, which means I want to go down 1 and 1, 2, 3, run 3. Down 1, 1, 2, 3. Now I could have applied that to applied my negative to the run. So I could go rise 1 and left 1, 2, 3, negative 3. Rise 1 and 1, 2, 3. Where this is useful is when you're graphing and you don't have enough room on the graph, so you've got to be able to go the other way. So this right here is a negative graph because it falls to the right. It's got a negative slope here with the negative 1/3. So this is how you'd graph the equation y minus 2 equals negative 1/3 x minus 4. Now let's move on to writing equations of lines. What is an equation of the line with slope 3 and y-intercept negative 5 in standard form? Now I'm going to have you write all of these into standard form. The reason for that is because if you can write it in standard form, you can write it in any of the forms. So they're not always going to ask for standard form. Sometimes they may just say, what is the equation of the line in slope-intercept form or in point-slope form? So this they wanted. To start off, we're going to have to look what we're given. We're given the slope, and we're given the y-intercept. Now, y-intercept, the way to write that is, we call that the b. So b is equal to negative 5. That means we're going to use the y equals mx plus b. So we start by plugging our numbers in. 3 for our x, negative 5 for our b. This is in slope-intercept form. In order to get it to standard form, which is going to be the ax plus by is equal to c, all I need to do is bring my x to this side over here. So I'm going to subtract 3x. So we got a negative 3x plus y is equal to negative 5. Now, if your problem ever reads, make sure you have a positive x, then the way we get rid of this is we change our signs by multiplying through by negative 1. That changes everything. So this changes to a positive 3x. Distribute the negative 1, we get a negative y and a positive 5. So these are both in standard form. Okay, this one just has the a value positive, this one has it negative. But your homework should count for both. All right, let's take a look at another type. Now we're looking at equation given a point and also given a slope. So this means we're going to use point-slope form. Point-slope form, remember, is y minus y1 equals mx minus x1. So as we plug our numbers in, we're going to get y minus the y-coordinate. Well, that's minus 5. Our slope is 2, and x minus a negative 1. Now we've got to change our signs here. Y minus 5 equals 2, x plus 1. This right here is now in point-slope form. Now to get to standard form, we have to now take it to slope-intercept form. So the first thing we have to do is get rid of our parentheses by distributing. So we're going to multiply the 2 through set of parentheses. We get 2x plus 2 equal to y minus 5. And if we want this to look like y equals mx plus b, we got to get the y by itself. So we need to get rid of the 5 by adding 5 to both sides. Y is equal to 2x plus 7. Now that we have it in slope-intercept form, next we're going to plug it into standard form. So we'll write that up here. So that means I need to move my 2x over, so it's going to end up being 2x plus y equals 7. And if you change it to make it positive, you multiply everything by negative 1 and make it a positive 2x minus y equals negative 7. Once again, your homework doesn't care which way you do it. All right. I want you to pause the video now, work out problem C, write your equation in standard form. All right, so we take our line, our slope is negative 3, our point is negative 1, 4. So y minus 4 equals negative 3, x minus negative 1, which changes to become x plus 1. So this is in point-slope form. Now to change it to slope-intercept form, we're going to distribute the negative 3 through. That gives us negative 3x minus 3. Add the 4. That gives us y equals negative 3x plus 1. That's in slope-intercept form. 1 is our y-intercept. Negative 3 is, once again, our slope. And then the last step is to change this into standard form, which means I need to add 3 to both sides, and I get 3x plus y equals 1. So, like I said before, it's not always going to ask you to put it in standard form. It may ask you to put it into slope-intercept or 2-point slope form, so make sure you always read the directions carefully on asking when they tell you what form they want your answer in. All right, so let's look at example 4, using 2 points to write an equation of a line. What is the equation of the line at right? Write the equation in standard form. So once again, you could find your slope by using the graph, and then you can pick a point and solve it. I'm not sure what my computer's doing right now. Now, one way to do it is also the original way when you're given 2 points, which is what I'm going to go back over with you here. So I'm going to take 3, 5, and I'm going to subtract negative 2, negative 1. So to find my slope, I'll take the y's, 5 minus a negative 1, over 3 minus a negative 2. Change my signs here, which makes this 5 plus 1 is 6, and 3 plus 2 is 5. So our slope is 6/5. So now you have to choose which one of these 2 points do we want to use. We have our slope, we just need a point. And most of us will always choose the 3, 5. And it doesn't matter which one you choose, you'll get the same answer in the very end, in standard form or slope-intercept form. But in point-slope form, you'll get something different. So let's put it into, begin by starting, and you're going to put this in point-slope form. So we're going to take the point, 3, 5, and we're going to use our slope of 6/5. So y minus 5 equals 6 over 5 x minus 3. Now before we've looked at slopes and equations that have no fractions or very few fractions. So now let's take a look what happens when we start to write an equation using fractions. So we multiply through here. So this gives us 6 over 5x. Now we're going to multiply this by -3. Now remember, when you multiply whole numbers times a fraction, you put it over 1 to help remind you what you're going to multiply. So the numerator times the numerator. 6 times 3 is a -18. 5 times 1 is 5. So I went ahead and put the negative sign out here so we wouldn't forget it. And it's equal to y minus 5. Now, as I add 5 to both sides, okay, I have to add it in fifths because I need to be able to add our fractions. So that's one of the rules in order to add or subtract fractions, is you must have like denominators. So I've got to figure out, how can I take this fraction, put it in fifths, and still have it equal 5? The way we do that is by multiplying the denominator times the whole number. So 5 times 5 is 25. 25 fifths is the same thing as 5. So we haven't changed its value, we just changed the way it looked. So now we can add or subtract our numerators. So in this case, we have a -18, a positive 25, which means I subtract, and I'm going to get a positive 7 over 5. Bring down our plus sign, because 25 is bigger than 18, it's positive. Nothing happened to the 6 over 5x, and that's equal to y. So this right now is now in slope-intercept form. So now the last step is to get this into point slope, or standard form. Standard form means I need to get rid of my 5. We want it to have all whole numbers. So to do this is I'm going to multiply both sides by 5. So basically I'm going to distribute a 5 through our entire equation. So this is going to give me a 5y equals 5 cancels with this bottom 5, gives us 6x, and it cancels with this 5, giving us 7. So the last step is to subtract 6x. Negative 6x plus 5y equals 7. And if we were going to change the a to positive, I just multiply everything by -1 and get 6x minus 5y equals a -7. So no matter what point you choose, your answer will always come out to be the same at the very end. All right, so this was given 2 points in writing the equation of a line in standard form. So let's go to the last question here. Writing equations, horizontal and vertical lines. This one is one of the ones that is missed the most, but it's actually one of the easiest. What is the equation for the horizontal and vertical lines through 2, 4? So we're going to have a horizontal line and a vertical line that's going to go through this point. So let's graph that point. 2 on the x and 4 on the y. Now we're going to have a vertical line that's going to go through here and a horizontal line that's going to go through here. So this will be our vertical line, and this will be our horizontal line that's going to go through this point. So now, what are the equations of the lines? Well, what I'm going to ask you is, which axis did this line right here cross, this vertical line? Well, it crossed the x-axis. So therefore, our equation should read x equals, and wherever it crossed, which would be 2. So this line right here has an equation of x equals 2. This line right here is a horizontal line. It crosses the y-axis, so our equation will read y equals. It crosses at 4, so we say y equals 4. And so this equation will read y equals 2. So if there is just a horizontal or vertical line, it's only going to have an x equals or a y equals. Depending on which axis it crosses is what variable you use. So if it crosses the x-axis in a vertical line, it's going to be x equals. If it crosses the y-axis in a horizontal line, it's going to read y equals. So if I drew another line here and I said, what is the equation of this line? Assuming I moved it over correct. Okay, this line right here, we would say this is crossing the x-axis, so it would be x equals. It crosses at -3, so our line would be x equals 3. All right, so this concludes our lesson on writing and graphing lines in the coordinate plane.